Myself Nargis Khatun. I am going to mm, explain my dissertation topic carbohydrates. Introduction. Carbohydrates are polyhydroxyaldehydes or ketones. The word carbohydrate is derived from their general formula CnH2n that makes them to be hydrate of carbon. They are primarily produced by plants and a very large group of naturally occurring organic substances. Most important carbohydrate in the body is glucose. Classification. Carbohydrates are classified into two main classes, sugars and polysaccharides. Sugars. Sugars are further classified on the basis of their behavior on hydrolysis. Monosaccharides. Mm, The simplest form of carbohydrates, mono means one and saccharide means sugar that cannot be hydrolyzed further to be classified. Polyhydroxyaldehydes are called aldoses, example glucose. Polyhydroxyketones are called ketoses, example fructose. Oligosaccharides, disaccharides, trisaccharides. The D and L notation. The notation D and L are used to describe the configurations of carbohydrates. In a Fisher position, the carbonyl group is always placed on the top position for monosaccharide. From its structure, if the OH group attached to the bottommost asymmetric center is on the right, then the compound is a D sugar. If the OH group on the left, then the compound is L sugar. Epimers. Epimers are stereoisomers that differ in configuration of only one asymmetric carbon of enantiomers or diastereomers. Example D-glucose and D-mannose are C2 epimer. Cyclical structure. Monosaccharides having 5 or 6 carbons in the chain gives cyclical structure in an aqueous solution via internal hemiacetal, and aldehyde can react with alcohol to form a hemiacetal or hemiketal. A ketone react with alcohol to form a hemiketal formation. Anomeric carbon. Anomeric carbon is a term used to describe the epimeric carbon in anomers. The cyclic structure exists in two different configurational forms. If the hydroxyl on the anomeric carbon is below the plane of the ring, it is said to be the alpha position. If above the plane of the ring, it is in the beta position. In glucose, the C1 carbon atom is called the anomeric carbon atom, and the alpha and beta forms are called anomers. Mutarotation. When pure alpha and beta anomers of sugars are dissolved in a solvent, they are measured by specific rotation will change over time until converging on an intermediate value. This change in observed specific rotation is called mutarotation. Example D-glucose. Reducing and non-reducing sugars. Some acetals or ketals do not exist in equilibrium with their open chain carbonyl group containing forms in neutral or basic aqueous solution. This cannot be oxidized by reagents such as Tollens reagents Ag plus NH3OH minus or Br2. So these are referred as non-reducing sugars, whereas some hemiacetal or hemiketals exist in equilibrium with the open chain sugars in aqueous solution such as glucose. These sugars can reduce an oxidizing agent such as Tollens reagent or aqueous bromine and are thus classified as a reducing sugars. In fact, all aldehyde bearing compounds can reduce Tollens reagent, and this includes aldoses such as glucose. Aldoses have a aldehyde group that can get oxidized to carboxylic acid and in turn and in turn can reduce Tollens reagent to participate silver. In a test tube, the silver participates to form a silver mirror on the sides of the tube. This is used as a qualitative test for aldehydes, which includes reducing sugars reactions. Monosaccharides contain carbonyl functional group and alcohol functional group, so it can be oxidized or reduced and can react nucleophiles to form corresponding products. Epimerization. In the presence of base glucose may convert it into D-mannose via the thermal removal of hydrogen at C2 carbon followed by protonation of the alanine. The reduction. The monosaccharide contains carbonyl group which can be reduced by the reducing agents such as NaBH4. Oxidation. Bromine water oxidizes aldehyde functional group but it cannot oxidize ketones or alcohols. Therefore, aldose can be distinguished from ketones by observing reddish brown color of bromine. The oxidized product is an aldonic acid. Oxazone formation. Aldose and ketones react with equivalent of phenyl hydrogen to produce phenyl hydrogens. In contrast, both C1 C2 react with three equivalent of phenyl hydrogen to form a bis hydrogen known as an oxygen. The Daft degradation. Aldose chain is shortened by oxidizing the aldehyde to COH. The decarboxylation in the Raft degradation, the calcium salt of an aldonic acid is oxidized with hydrogen peroxide. Ferric ion catalyzes the oxidation reaction which cleaves the bond between C1 and C2 forming an aldehyde. The calcium salt of the aldonic acid prepared from oxidation of an aldose with an aqueous solution of bromine and then adding calcium hydroxide to the reaction mixture. The Killany-Fisher synthesis. An aldose carbon chain can be increased by one carbon in a Killany-Fisher synthesis. It is the opposite of Raft degradation reaction. This synthesis leads to formation of a pair of C2 epimers. Acknowledgements. Reference. Thank you.